Inshallah, in this class, we see some more questions on consistency and inconsistency. In the previous class, we have understood in detail how to find the rank and consistency and inconsistency. So, those who have not referred the previous class, I request to first see the previous part of this chapter. Okay. So, let me continue here. You already know that to find the rank, first we have to make this two zeros using R1, then this 0 using R2. Let me first make this one 0. This is R2, therefore R2 implies, because this is 5 3 5, multiply this with 5 15, this 3 15, multiply R2 with 5 R2 minus 3 with R1 3 R1. In the same way, R3 implies, because it's 7, multiply with 5 and multiply with 7 35 minus 0. So R3 5 5 R3 minus 7 R1. So let me change here. So if the numbers are difficult, then we can do the rough work. Okay. So let me change now. We should not change the first row. We are not changing the first row. Right as it is. Now second row, I want to show the rough work how to do. 5 R2 minus 3 R1. 5 R2 means multiply all the elements with 5. 5 into R2. 5 3s are 15. 5 6 are 30, carry 0, 3 13, 5 2s are 10, 5 9s are 45, minus 3 R1, minus 3 R1. So multiply with minus 3 all these numbers, minus 15, minus 9, minus 21, and minus 12. So let me add these numbers 0, 1, 21. This is minus 11, 33. Now let me write here 0, 121 minus 11, 33. In the same way, let me do the rough work for another row. What is the another row here? R3 implies 5 R3 minus 7 R1. Now multiply with 5, 5 into R3. So let me multiply this with 5. 5 10, 5 7s are 35, 5 into 2 10, 5 10s are 50, 5 5s are 25, minus 7 r 1 7 r. So multiply minus 7 35 minus 21 minus 49 minus 49 minus 28. So see here what is left here, 0. This will become minus 11 minus 11, and this will become 1. And what is here the next one? See here 20 minus 3. So we left with 0 minus 11 1 minus 3. See next step, whenever we get some common in the rows, we must take the common. So in the second row, if you see, we can take 11 common. So take common 11. R2 implies R2. Common means dividing by 11. So what is left here? 5 3 7, and this is 4. Now in the second row we are taking common 11, so it will become 0. 11 ones are 11 11s are 11 ones are 11 3s are 0 minus 11 1 minus 3. Now see here, the last step is we have to make this one 0. So R3 implies R3 plus R2 minus 11 plus 11 0, R3 plus R2. So it will become 5 3 7 4 0 11 minus 1 3. R3 plus R2, 0 plus 0 0 minus 11 plus 11 0, 1 minus 1 0, 3 minus 3 0. Now watch here, put a line here. This is the rank of A. Sorry, this is the rank of A. This is the rank of A. Therefore rank of A equals to, you see, because we got here 0, we will not count this row. We count only 2 numbers here, 2 rows. So rank of A is 2. And rank of AD, it is also, because here also 2, here also 0, we don't have any numbers in this, so this is not countable. So the rank is 2. Rank of AD is 2. Whereas the variables are, we are having 3 variables, x, y, z. So the condition is like this: rank of A equals to rank of AD but less than n. So this condition we have already written in the previous class, that it's consistent and infinite solution. Therefore, the system of equations are consistent and infinite solutions. Infinite solutions. Infinite solutions. Now, how to find the infinite solutions here? Let me again attach this with x, y, z. This is 5x plus 3y plus 7z equals to, see here again I am writing, therefore 5x plus 3y plus 7z equals to 4. 5x plus 3y plus 7z equals to 4. Now here x is 0, this is y, 11y minus z equals to 3. Now actually when we have three variables we must have three equations, but all this becomes 0, we don't have the third equation. Therefore, three variables, three unknowns cannot be found out by taking two equations. So this infinite solution method is, we are having one less the rank. No, variables are three and rank is 2. See here, the parameter, the formula of parameter is n minus r, 3 minus 2. 3 minus 2 is 1. That means of this x, y, z, one value must take by ourselves. Like we take some else value k, suppose x equals to k or y equals to k or z equals to k, then the other two values will get from the equation. Don't take this equation, the smaller equation. From this equation either you take the value of z equals to k or y equals to k or y equals to k. Let me take y equals to k. It's very easy. If it's sent here, it will be, we will get that is z. So it start like this. Let y equals to k. Y equals to k. K belongs to any natural number, any real numbers. Okay, so substitute here, 11 into, we have taken y as k minus z equals to 3. Now bring this minus z here, bring this 3 here, therefore we will get the value of z equals to 11k minus 3. So we got y equals to k and z equals to 11k minus 3. Now let me substitute these two values here. We'll get the value of x. So 5x plus 3 into y, we kept 3 into y, we kept the value of y as k, the value of y is k, plus 7 into z is 11k minus 3 equals to 4. Now if we solve these values, we'll get the value of x, 5x plus 3k plus 77k minus 21 equals to 4. Now see here, 5x equals to minus 21 on the other side plus 21, 21 plus 4, 25, 77 plus 3, 80, 80k on the other side minus 80k. Let me take common 5, 5, 5, 5 will get cancelled. So 5x equals to, if we take 5 common, 5 into 5, 5, 5 16s are 80k, 5, 5 cancel. Therefore solution is, we get the value of x equals to 5 minus 16k and the value of y equals to k and z equals to 11k minus 3. So this is the procedure to solve when the equations we got inconsistent solution. One of the value must take as k. Let me continue with other questions. Now you see here, next question. For what values of lambda and mu the following equations have no solution, unique solution, infinite solutions? Now watch carefully. Let me first write augmented matrix. Its value is 1, 1, 1, 6, 1, 2, 3, 10, 1, 2 lambda. First let me make this two zeros and this zero. Let me change into equivalent form. After that we will see what are the conditions and situations. Okay, the first one, let me make this 2 0 very easy. No, first one, r1 implies r2 implies r2 minus r1 and r3 implies r3 minus r1. R1 implies r1 minus r2 minus r1, r3 minus r1. So it will change to, first you write as it is 1 1 1 6 1 minus 1, 0, 2 minus 1, 1, 3 minus 1, 2, and 10 minus 6, 4, 1 minus 1, 0, 2 minus 1, 1. This will become lambda minus 1, lambda minus 1. This will become mu minus 6. Now the next step is R3 implies. Now we must get 0 here. So we use R2, R3 minus R2, R3 minus R2. So it will changes to, no, 0 minus 0 will be 0, 1 minus 1 will be 0, lambda minus 1 minus 2 will be lambda minus 3, mu minus 6 minus 4 will be minus 10. So now here let me continue. See here, now we have to understand this little bit. I will take one example. Okay, see here, suppose we are having 1 1 1 6 0 1 2 4 0 0. See here some numbers. Now let us see. First one, the question is, what is the condition for no solution? We already know that no solution means rank of A should not be equals to rank of B, AD. So that way is possible if the rank of A is 2 and the rank of AD is 3. Suppose if we have like this, the rank of A will be 2, rank of A will be 2, the rank of AD will be 3. Suppose you are having any number here other than 0, other than 0. Then we say that the rank of A is not equals to rank of AD, therefore inconsistent, no solution. For that we must have here 0, here we must have 0. Therefore for no solution, lambda minus 3 should be equals to 0. Whereas we should not have 0 here. If we have 0, then it will become rank, this will also become rank 2, that will be infinite solution. So here you should not have 2, you should have any number else than 0, other than 0. So we should not have 0 here, that is mu minus 10 should not be equals to 0. Therefore lambda equals to 3 or mu equals to is not equals to 10. This is the first condition. And second question is unique solution. Second condition is unique solution. Unique solution is possible if rank of A is 3, rank of AD is 3, rank of A is 3, rank of AD is 3. That is possible if we have some number here other than 0. Suppose we are having 3 here. So the rank of A will be 3, the rank of AD will be 3, consistent and unique. So even if we have 0 also here, even if we have 0 also here, then also rank of A will be 3. We are having suppose 2 here. The rank of A will be 3. The rank of AD will also be 3. AD means complete. Okay. In this case also, that means here we should not have 0. Here we can't have any number. You have any number, even 0 also, the rank is 3. So this should not be 0 for rank 3. If this is not 0, this is not 0, then we will have the rank of AD also 3, A also 3. For unique solution must have the rank equals to 3. That means this number should not be 0. Therefore lambda minus 3 should not be equals to 0. Whereas we can have any number at the mu. So mu belongs to any real number. Okay, bring this minus 3 there. So lambda is not equals to 3. Mu belongs to any real number. So the last condition is infinite solutions. Infinite solutions. So for infinite solution, the rank should be of A should be 2, the rank of AD should be 2. For that, must have both zeros. The rank of A will be 2, the rank of AD will be 2. So for infinite solution, this should also be 2, this should also be 2. Therefore, lambda minus 3 should be equals to 0. This also be 0 and this should also be 0. Lambda minus, mu minus 10 equals to 0. That is lambda equals to 3, mu equals to 10. So we must get the values of lambda equals to 3. If lambda is 3, this is 0. Mu equals to 10, this is 0. Then both the ranks will be 2 infinite solutions. So these are the conditions for unique solution, no solution, and infinite solution. The next question you see on the board, find the value of k, values of k. The following equations for the following equations to have solutions. Also find the complete solutions. See here, three equations are given. The question is to write the conditions for which the equations have solutions. Whatever the question is given, see here. First, we have to change into equivalent form. I have done this question shortly, okay, to save the time, because if we do all the question, it will take lengthy videos. See here how to make this two zeros: R2 minus 2R1, R2 minus 2R1, R3 minus 4R1, R3 minus 4R1. So when we do this one, we got these two zeros, okay. Again, to make this 0, we use R3 implies R3 minus 3R2, R3 minus 3R2, R3 minus 3R2. So we get this also 0, and this is also became 0. Till this step we have done already many questions. Now you do till this question steps. Now I'll explain here. See here, already we got this 2, this one 0, no? So the rank of A is 2. The rank of A is 2 because this is 0. Now, for have consistency, we must have this also 0, because if this is number, then rank of A will be 2. Number other than 0 means rank of A 3, inconsistent. For to have consistent, this must also be 0. This must also be 0. Therefore, for rank of AD equals to 0, rank of AD equals to 0, this number should be 0. Therefore, we write for consistent, we must have k square minus 2k plus 2 equals to 0. This is the quadratic equation. Either you take the values from calculator, or let me factorize this one. So to factorize 2 ones are 2 minus 2 minus 1, okay, k square minus 2k minus k plus 2 equals to 0. If we take common here, k left with k minus 2. If we take common minus 1, again we left with k minus 2 equals to 0. So k minus 2 into k minus 1 equals to 0. See, we get the values k equals to 1 or k equals to 2. So for k equals to 1 or k equals to 2, the given equations will be consistent. For k equals to 1 or k equals to 0, the equations will be constant. Also, the question is given to write the complete solution. So let me take for k equals to 1, then k equals to 2. If you put k equals to 1 here, what is left here? 1 minus 2 will be minus 1. So this, when we keep k equals to 1, it will be 0. So let me solve this one. Here we kept the value of k equals to 1. So we got this equation. So what is the equation here? X plus y plus z equals to 1. X is 0 minus y plus 2z equals to minus 1. So let me take one of the value as k. You take k1, because for first condition let me take k1, for the second condition let me take k2. See here, let me take z equals to k1. When we keep z equals to k1, we'll get the value of y minus y, no, bring this y here, 1 here. So y will be 1 plus 2k1, 1 plus 2k1. Now keep the value of z and y in this equation 1. X plus y plus z equals to 1. We kept the value of y 1 plus 2k1 and the value of value of z as k1 equals to 1. 1 1 will get cancelled. 2k1 plus k1 is 3k1. Bring on the other side minus 3k1. So one solution will be x equals to minus 3k1, y equals to 1 plus 2k1, z equals to. Now when we substitute k equals to 2, we'll get this equation 1 1 1 1. So again you substitute x plus y plus z equals to 1 minus y, because x is 0, minus y plus 2z equals to 0. Now let me take one of the value from this as k2. I am taking z equals to k2. So keep z equals to k2, minus minus will get cancelled. Y we get the value 2k2. Let me substitute z and y here. The value of z is k2. The value of y is 2k2. So we get the value of x as 1 minus 3k2. So this is another solution. So inshallah, let we continue in the next class. Okay, next class inshallah we will see about the eigenvalues and eigenvectors, inshallah. Oh, not eigenvalues and eigenvectors, but inshallah let we see the consistency and inconsistency for homogeneous equations, inshallah. So let we continue in the next class.